Good afternoon, ladies and gentlemen, here in Santa Clara, California. Good morning, good afternoon, good evening. If you're following this lunchtime keynote out there on the World Wide Web, wherever you might be, we have Microsoft's high-level talk now. We've had that morning session. This is going to be, I understand, a higher level. Tim O'Brien we have from Microsoft. Let us hear then about Azure from the highest possible level, and let's make sure that we don't steal any more time. Tim O'Brien, thank you, sir.
Thank you. Good afternoon. Thanks, everybody, for coming today. I know we're, 3 days into a 4-day conference, so the afternoon of the third day, I think, meets the bar for home stretch. That, and I'm competing with food, I understand. So thank you for coming to the session. What I want to do today is help put some framing around this move to services, this move to the cloud, and hopefully do so in a way that helps inform some of your thinking either about strategies that you're planning in the near term or maybe strategies that you're executing on today. And the way we want to do this is to really frame this in terms of this idea of disruption. And one of the things that I find most curious about this topic, about this space, is all the colorful words and terms that are applied to what's happening in our industry today. There's something about geological references that tech bloggers and trade press seem to like a lot, with talk of tectonic plates grinding together in seismic shifts. But disruption is actually a good word in the sense that it almost ensures that we don't underestimate the impact of what's possible. And I know that it stands to reason that anyone who spends their time day in and day out dealing with the practical realities of running enterprise computing, running an IT organization, probably has a built-in filter for marketing hyperbole. I'm right there with you. But in this particular case, disruption, I think, actually accurately describes what's happening. So what I want to do today is start from, I think, a little bit different place. When I looked at the program guide and saw all the incredible breadth and depth of sessions and keynotes, there was an amazing array of talks in terms of left to right strategy, deep dives into technologies. What I'd like to actually do is take a step back from that, take a step back from the technology industry, and just spend a few minutes, not the whole session, but just a few minutes, looking at historical examples of disruption and see what kind of lessons we can tease out of that. Some of them will be mind-numbingly obvious. Others will be a little bit more subtle. But let's get started and see what we can do. If you go to enough of these conferences and you go to enough talks on cloud computing, or you read enough articles or white papers, you can sooner or later somebody's going to talk about the disruption that was the automobile business. What I'm not going to talk about here today is much about the end state. I want to talk about what happened along the way, because there are some things that took place throughout this particular transition that are actually very relevant to the cloud discussion today. We have an existing technology in what was essentially the transportation business at the time, the horse-drawn carriage. The disruptive technology was the application of a motor to the carriage, doing away with the need for the horse. And what's interesting about this is the way people thought about it. A lot of the disruption that took place in this particular time frame was not unusual in that the invention, the engineering, all took place decades in advance of mass adoption. A lot of this sort of thing was happening in the mid to late 1800s. This particular photograph is of the patent motor wagon that Carl Benz produced in 1885. And what's interesting about this is if you were to ask someone in the late 1800s, what in the world is this thing? I don't get it. I don't see the horse. How does it work? The answer you would have gotten back would have been some version of horseless carriage. In other words, the disruptive technology was framed in the context of the existing technology. It would be like someone asking you, what's cloud computing? And you get an answer saying, well, it's like client-server computing where you don't have to deal with clients and servers quite so much. And one of the cautionary tales here is just not to get caught into the trap of necessarily looking at what's possible with the new disruptive technology purely through the lens of what came before it, because that'll have the artificial effect of just limiting what's possible. We refer to this as horseless carriage syndrome. I think Henry Ford said it best when he said, if I'd asked people what they really wanted, they just would have said faster horses. So we all know how the story ends. Henry Ford comes along, pioneers mass production, drives the price point down, and suddenly everyone can afford this. And the economics of acquiring this actually overcame a lot of these barriers and skepticism that was talked about for decades. Everything from, these things are too expensive to there's an extreme supply of chauffeurs to drive people around. It'll never catch on. When people talk about cloud computing, this example comes up a lot. There are other disruptions that fit this shape. Electricity as a utility disrupting Westinghouse, who at the time was selling generators as fast as they could make them. But not all disruptions take this particular shape. There are other very, very common shapes that we can look at. We'll just put up one more example here, which is another exciting business, the oven business. This is a mature business, if there ever was one. Ovens have been around a long, long time. And the disruptive technology was the use of microwave radiation to cook food. A lot of this invention, this engineering took place after World War II. So this new technology was taking place during the nuclear age, and you have to explain to people how radiation can help you in the kitchen. That sort of freaked people out a little bit. But it was not unusual in the sense that this predated mass adoption of the product by several decades. The first microwave showed up in the market in 1954. It cost $2,000. It was too expensive, and no one was going to buy it. But what was interesting about this was how it was positioned. Some of this may sound very familiar to the cloud discussion today. This was never positioned as a wholesale replacement for the existing oven. The benefit here, and I'm dating myself a little bit, for those of you who grew up in the 70s, some of this may sound familiar. The benefit here was saving time. Saving time in the kitchen for the subset of kitchen tasks that don't require the existing technology. And people thought, hey, that's great. I love saving time. Time saving sounds like a great thing. I'd love to go get some time savings. What exactly is this list of tasks that I can do? People literally did not know what to do with it. Starting to hopefully sound a little bit familiar. So people, the advertising, if you go back and look at some of the vintage advertising that was being propped during the 70s, the attributes, the features of the product got very, very little ink in the print ads. And 90% of the ad was, here's 10 recipes you can make today. Here's 10 things you can do with this product. It was all educational. Right? Buy this set of Corningware dishes and we'll give you a free microwave cookbook. It was all about educating the market about here's what you use the new technology for, here's what you should use the existing technology for. And once that partitioning became clear, and people figured out that if I need to reheat leftovers, I use this thing, and if I need to bake a cake, I use this other thing. And once people started to figure that out, that really set the table for the end state today, which is one in which every modern kitchen has both of these things, and everyone who knows their way around a kitchen, and I'm not arguing that I'm one of those people. There are evidently people in the world who know their way around a kitchen, know exactly which of these two tools to use for whatever task they're trying to accomplish. And the analog to the cloud discussion is when we talk about the benefits of cloud, we talk about great economics, business agility, only pay for what you use. I mean, the list goes on. And every customer conversation we have is one in which the customer nods in approval and says, absolutely, I want all those things. What exactly am I supposed to do today to get to those? Show me the apps. Show me the workloads. Tell me what enabling technologies I can deploy today to get me on the path to getting those benefits, because all you've told me about is the benefits. You haven't really told me what to do or why I should do it. So enough about microwaves and cars. Let's talk about cloud computing. The existing technology today, referred to most often as traditional IT or client server. We have this new disruptive thing called the cloud. This actually is not stock photography. This is a photograph of the inside of one of our Gen 3 containers in our Chicago data center. And I think it's worth drilling down below a little bit just what cloud is and talk about some of the enabling capabilities that really make this interesting. It's a combination of hardware and software advances, and it doesn't matter at what level of the stack necessarily it's delivered, at the infrastructure layer, the platform layer, or the software layer. There's a set of enabling capabilities that you have to be able to implement in order to deliver the promise of what cloud computing provides. And I'm talking about things like demand pooling, virtualization, automated service management, self-service provisioning, dynamic scaling. The list goes on and on and on. So the question we want to try and figure out today, or at least think about, is what is going to be the end state for the implementation of these capabilities? If you take these capabilities and you implement them in a shared environment, a public environment that anyone can come use on a pay-as-you-go basis, that's how most people refer to, or what most people refer to as a public cloud. If you take that same set of capabilities and you implement them in a dedicated fashion inside the confines of a given business or entity, that's what most people refer to as a private cloud. And then at this point, the math gets very, very easy. One potential outcome is we have a combination of both. Now, the thing that's going to determine, or the set of things that's going to determine what the outcome is here, is fairly multifaceted. There's a set of technology enablers. So, for example, in the development community, there's broader and broader uptake of things like parallel programming and taking advantage of many-core and multi-core. So you see technical catalysts that will drive this forward. There's a set of business and regulatory catalysts that are grappling with this set of issues. You see this today in privacy on the web, contextual advertising, the data sovereignty issue that comes up certainly in the EU and even more and more here in North America. But there's also a set of economic levers that are going to have a big, big impact on how this plays out. And if you attended the Windows Azure session this morning, you heard Mark Hinsbo talk a little bit about the economic underpinnings of why this is so compelling and why the economic forces are potentially more powerful than the sum total of the other forces combined. So I'm actually going to expand on that quite a bit and really start with what is at the root of cloud economics? What is really at the root of what makes it so compelling? And there's two aspects of it that I want to talk about, the supply side and the demand side. First, let's talk about supply-side economics, the economies of scale that come from the supply side. And this really applies to anyone building a large data center. It could be a third-party provider, like Microsoft or any of the companies that we compete against. It can be any number of companies that are building large-scale infrastructures. The economies of scale, the sources of scale economies on the supply side, come from a fairly focused set of things. First and foremost, I think the most obvious one is purchase price on hardware. If you're buying commodity hardware in a standardized configuration at very large volume, you're going to get a good deal. If you're buying in bulk, you're going to get a good unit price. So that's kind of a no-brainer. Electricity is another one. This is becoming one of the fastest growing aspects of total cost of ownership in the data center. And that's why you see people building out large infrastructures and large data centers doing so geographically close to cheap electricity. You see companies negotiating with local utilities to make sure they get a good deal. So the power management is actually becoming a very important piece, and there are tons of scale economies that you can achieve there. Labor is another big one, and there have been a number of tried and true data center staffing metrics ratios that we've all used for years and years. They go along the lines of, I need a person to manage every 100 to 150 servers, or I need a database administrator for every terabyte of data, or I need a network administrator for every gigabit of bandwidth. And what happens on the supply side when you implement a lot of these capabilities, particularly the automation capabilities, where you have hardware components that fail in place and don't have to be swapped out immediately, where you have automation behind a lot of the service management that's going on. You can literally go from one person looking after 100 or so servers to potentially looking after 1,000 or thousands of servers. It's an order of magnitude greater. And so when you sum all these up, you get a TCO picture that's pretty compelling. And we've actually modeled this out internally and found that the TCO per server in a 100,000 server data center is less than half of the TCO per server in a 10,000 server data center. It's just fairly compelling supply-side economics. So the other flip side of this coin is demand. This is about people. This is about people using apps, and this is about the patterns in which they use those apps. And the big culprit here is workload variability. That's the thing that really drives down server utilization, because if you have to over-provision to make sure you hit the peaks, when it's server idle, you're still paying the depreciation, you're still paying for the people, you're still paying for the lease on the floor space. And so the goal here is if you can aggregate demand, aggregate these workloads, aggregate these applications in a shared environment, you will effectively diversify away a lot of that variability. Think of your portfolio of applications the same way you'd think of a portfolio of stocks. The more diversified it is, the less subject it is to volatility, to wild peaks and wild spikes. And so there's a number of different sources here that cause this variability. Some of it is just plain old randomness in the way people use apps. You may have a steady state sort of loaded profile on a server that says it's 25% utilized, but sometimes it's 80%, sometimes it's server idle. And you have to make sure the capacity is there to meet those peaks. Hence, we have the utilization situation that exists in many IT shops today. Another is time of day, and Mark Hinsbo talked a little bit about this morning, where if you do business in the United States and your infrastructure is busy during the working hours in North America and not a lot is happening at nighttime because there's nothing else running on that infrastructure, pooling that demand with workloads that are running in Asia and Europe effectively gets you a much more predictable loading profile that is busy 24 hours a day. And so, you start to think through these different enablers of diversifying away variability, and the bigger the scale, the more likely it is to happen, and it sort of plays into the public versus private cloud debate to the degree that public clouds are, by definition, at a bigger scale than private cloud. The last thing that probably has the biggest impact on that particular debate is industry-specific variability, sometimes known as seasonality. If you're in the retail business, you have an infrastructure that needs to stay up and work during the month of December, and you're willing to live with low server utilization during the other 11 months of the year. If you take that same set of applications and workloads and put them in a shared environment, that shared environment is going to be busy during the month of December because of you and all the other retail companies that are using that infrastructure. It'll be busy during Mother's Day and Valentine's Day because of all the online flower ordering apps that are running on that infrastructure. It'll be busy during the month of April because of all the tax preparation software that's running on that infrastructure. And you start to aggregate all these industries and all this seasonality, and all of a sudden you've got a much smoother, much more predictable loading situation on your infrastructure. And once you have that, you can get closer and closer to this theoretical 80% utilization. If you implement these cloud capabilities in a dedicated private environment, you don't have the ability to diversify away industry-specific variability. It's just the seasonality of your business is what it is, and if there's a business reason, cost-benefit analysis that justifies that, that's great, but just not all these are easily achievable in a dedicated environment. So the question here is, what are the scenarios, given all these economics are so compelling, what are the scenarios that customers are using today to deploy cloud applications? And some of these were touched on this morning. I'm going to expand upon them a little bit and look at some of the canonical scenarios that are really grabbing enterprise attention today. One is this predictable bursting scenario. Even if the loading on a server is predictable, it doesn't matter. You're still overpaying when you're in the trough. And a lot of business applications are very, very predictable. Think of a financial application. You know it's going to be busy at the end of the month when you're closing the books. Despite that, the economics associated with that set of servers probably isn't very good. Another is the flash crowd or growing fast scenario. I had an interesting experience at home a couple of months ago. My wife was watching Oprah Winfrey in the other room. It was just white noise in the background. And I overheard the words web server mentioned on this show. Thought, hey, that's not a word you hear on Oprah very often. What's this all about? And the context of this was the Oprah Favorite Things show, where she gets on TV and says, hey, here are all my favorite products, and I love using all these different things, and boy, you should too. And it's usually a mixed bag of household names, household brands that we're all very familiar with and use every day, and these boutique, small business, micro brands that you've never, ever, ever heard of. And the context of this thing that I overheard was one of the small business owners who was fortunate enough to have gotten her scented candles on the list of Oprah's favorite things, and she described how within minutes of it being mentioned on the air, the website melted, the phone system went down, all the infrastructure just was brought to its knees. And that's fairly devastating from a business standpoint. I mean, you get a product placement opportunity like that, you need to cash that lottery ticket immediately. And if there's nobody there to take the online orders and so forth, you can imagine how much lost opportunity there was associated with that. It's not just startups, it's not just small businesses who get discovered, it's also large companies too. If you're putting out a marketing campaign on a microsite and it goes viral and takes off on YouTube and people love it, you need to be able to scale up to meet that, to get as much value out of that campaign investment as possible. We also have this scenario of unpredictable bursting. These are just burst scenarios that were unforeseen for any reason whatsoever. A good example of this, a sad example of this, is September 11th. Here we have the biggest news story, certainly in recent history, definitely the biggest news story of the internet era. So if you were in the news dissemination business, your website saw unprecedented traffic that you never could have predicted in any capacity planning scenario imaginable. And when the news cycle ended, things go back to equilibrium, and you need to come back down from a capacity standpoint. That's an example of something that can happen quite commonly, especially if more and more of your business is web-facing and kind of subject to the ebb and flow of consumers and customers using that. And lastly, we have this on-again, off-again scenario. I need 5,000 servers for an hour. I'm going to run this compute job, and when I'm done, I need to turn them off and go back to what I was doing. To do that on-premises, to do that in a dedicated fashion is pretty tough from an economic standpoint, and I'll talk a little bit later about why that is. But that's a fairly obvious scenario that right now tends to gravitate around scientific scenarios, engineering scenarios, high-performance computing scenarios. So if you look at your portfolio of applications today and say, hey, I can subdivide that portfolio into these 4 different buckets and loosely map what I'm doing today from an application standpoint, both build versus buy, both build and buy, and plot them against these areas, why wouldn't we just take all those apps and push them up into the cloud? Well, this is where we kind of take a step back and say, okay, let's talk a little bit about the practical realities of what's going on here. We've talked about benefits and great economics, and it's also compelling. But there's a lot of work that's been done in the analyst community to really take the temperature of enterprise decision makers, CIOs, a lot of managers such as yourselves to say, hey, what are the things about this that are keeping you up at night? This is a list of things from an IDC survey of CIOs, and the question was, hey, what are the challenges and issues associated with cloud adoption? This should not be a surprising list to anyone. I've left the numbers off because it really doesn't matter. These are the top box responses. These are the things that are basically stopping people from adopting cloud. You take that same audience and ask them what the benefits are, and you're going to get another fairly unsurprising list. Cost savings, pay for what I use, it's all very, very good. And so as we try to figure out what is the end state, at least what is the interim state at the very least for cloud computing, it's the tension between these two things, these two lists, that is really going to define kind of what the next 5 to 10 to 15 years looks like. And so we can actually go a level below this and take a look at what is this going to look like from a business segment standpoint, what's it going to look like within a given type of business. So let me explain this chart a little bit. The y-axis here is labeled public cloud economics. Let me explain what that means. We've talked about the ability to get better economics by operating at a bigger scale. The bigger scale in which the shared infrastructure runs, the better economics you can get by putting your app on that, depending on where you are today. And this is a relative statement. If you're a small business and you have 1 or 2 servers, the economics associated with those servers are probably pretty bad. And the benefit of putting those workloads in a public cloud is pretty good. So the smaller you are, the higher you're going to be up on this axis. If, on the other hand, you're already a big company, you've already got an efficient infrastructure, you're already operating at large scale, and you're pretty good at running a data center, you won't get as much benefit necessarily. The x-axis is labeled here private cloud preference. You could just as easily label it public cloud reluctance. They mean the same thing. This is a measurement of sentiment. And some of it is grounded in reality. Some of it is grounded in perception. These things take time to right themselves. But today, there's a measurement of private cloud preference that tends to vary by a segment of the business. So let's look at some of these different business segments. I should tell you that the size of the circle here is proportional to the number of servers in the world that are in that market segment. There's about 30 million servers in the world today, and it turns out that most of them are in the tens of millions of small businesses around the world. Each of those small businesses may only have a handful, but in aggregate, as a segment, this is where most of them are. That's why the circle is as big as it is. And many of these companies simply don't want infrastructure. They don't want servers. They don't want any kind of back end. They want to run their business online and call it good. So that's why you see it ranking so high in terms of the economic advantage that some of these smaller companies can get from simply just pushing their apps out the door and running their business online. And the reason they're so far to the right here is because they don't ask, or to the left rather. I'm getting my left and right goofed up. The reason they're so far close to the y-axis is because they just don't ask a lot of questions about private cloud. They don't ask any questions about doing anything in a dedicated way. And we'll talk about why that is as we look at some of these different segments, like mid-sized enterprises. You're getting a little bit bigger. You're getting a little bit better scale economy, so you'll come down a little bit on the axis, and you'll also nudge a little bit to the right. And the reason is a lot of these companies, the bigger you get, the more likely you are to operate in a regulated industry. The bigger you get, the bigger the data stores that you have, probably more time you spend worrying about bad guys breaking into your infrastructure and stealing things. I mean, a lot of the things that go along with being a big company will just sort of track with this axis. So it's not surprising to see large enterprises even come down even a little bit farther on this scale and nudge over to the right even further. The government is an interesting segment. It is the one segment that asks about private cloud implementation more so than any other we talk to. I don't think that anyone should be surprised by that. But the reason they're up as high on that axis as it is because it is, in a lot of ways, a collection of small businesses at the agency level. And this has actually been talked about fairly publicly, at least as it relates to the federal government here in the United States, over the past few years, where you've seen government officials quoted publicly saying, hey, we could do a better job of sharing counterintelligence data across agencies and so forth. And this has been written about, and it's funny, my wife, who knows absolutely nothing about IT or computers or servers or any of this stuff, will read these articles in the New York Times and say, honey, I don't get it. Aren't these things just all connected? Isn't it just one big, giant system? Isn't the data all in one place? And the answer, of course, is no, it's not. And that's why you see a lot of the kind of the small business level plot here from a y-axis standpoint. But if it was consolidated, it may operate at a scale that's as big, if not bigger, than some of the biggest public clouds on Earth. So there's a real opportunity in the public sector to drive some integration across these systems. Now, the other thing we can look at is say, okay, I understand how this all works from a segment standpoint. Within the confines of a given company, how does this partitioning work? Because as we look at those two lists of things, the benefits of cloud and some of the issues and challenges that are really causing people to think twice, the tension between those two can actually be applied to each and every application, each and every workload on an app-by-app basis. Not all workloads are created equal. They're all subject to different rules, regulations, business drivers, technical drivers, economics, and so forth. So let's take the small business example and just sort of look under the covers and say, okay, let's look at this from an individual workload basis. And again, the size of the circle here is proportional to the number of servers dedicated to that particular class of apps. And we can argue whether they should be bigger or smaller or in the right place. But you get the picture here. Web-facing workloads, I can't think of a compelling business reason why that shouldn't be in a public cloud infrastructure. The high-performance compute scenarios, it's as high on this axis as any other workload because the economics of trying to run supercompute jobs if the thing isn't busy all the time are pretty poor. Common Collab, interest in that category is fueling our Office 365 business that we'll talk about here in just a moment. And some of these other workloads that are a little bit farther off to the right, you can start to see why those might have a stronger preference for private cloud. Look at the custom business applications. If you've applied customizations to an application, you've paid money for those customizations, you still have ROI that you want to extract from that customization, and you can't run it in a public cloud because public clouds are all about any color you want as long as it's black, you may decide to keep that particular workload in a dedicated infrastructure until it's time to rewrite, re-architect, retire it in some way, shape, or form. Packaged business applications is a subset that you could break out into itself. CRM is obviously a very mature category as it relates to SaaS. That should be in a public cloud. But you start thinking about ERP and supply chain and others, again, it varies on a company-by-company basis. So what's going to happen going forward? What you're going to see is you've got this lower right-hand quadrant of, not a lot of economic drive necessarily and a strong preference for private cloud. These are actually going to be driven up into the upper left. Over time, a lot of these workloads will migrate, if purely on an economic basis, migrate into the upper left. And we just don't know what the time frame is, 5, 10, 15 years, but that will be directionally where things go. And so to the degree that the interim state here is going to be defined by these hybrid scenarios, it's going to be a kind of a mixed bag of things you keep on premises or in your dedicated environment or in a data center versus things that you do outside. It's going to be shaped by your ability to have a consistent set of technologies that span those two. And this is something that's really informed our strategy. I'm not going to talk about our products in any depth. I'd like to get to a couple of customer examples and talk about those. But this idea that there's consistency between what you're doing in a dedicated environment and what you're doing in a shared environment is a powerful idea. It's been a couple of the things that have informed our strategy around these offerings at the applications tier with Office 365. Aaron Kelly will be here tomorrow morning to keynote and go into a lot of depth on that particular set of offerings. And on the Windows Azure side, on the platform side, that Mark Hinsbo talked about this morning. And this consistency point is important because I had an interesting experience at a conference earlier in the summer where we had a booth at a conference. We were doing a demo of SharePoint Online for a customer. And this was an existing customer who was very familiar with SharePoint and was just very interested in moving their SharePoint servers out and just consuming SharePoint as a service in the cloud. So he went to the booth. We did a SharePoint online demo, and you know how you can always tell when somebody's underwhelmed by their body language and their facial expressions, and you get through the demo and say, hey, what'd you think? It's great, isn't it? And he said, nah, it's just SharePoint. And the response was, well, that's the point, right? You've got an investment in SharePoint. It's not just the money you paid for the license. It's your familiarity with the console. It's your knowledge of how to configure. It's your knowledge of how to customize, how to build your own web parts. It's your familiarity with the platform that actually continues to matter, even if you move that workload out of your environment. All that skill, all that familiarity, everything that you've learned, you get to continue to extract value out of. You don't have to start over and learn a new thing. That was the big takeaway. That and sometimes cloud services are tough to demo. That's a secondary learning. So what I'd like to do is just spend the last 10 minutes or so just talking about a couple of representative customer examples that I think are fairly demonstrative in how the interim adoption of cloud is going to shake out. And the first one here is Siemens. This is specifically the division of Siemens that does global services and consulting, Siemens IT Solutions and Services. And they had an application called a remote services platform. The purpose of this app was to deliver software packages and updates to some 80,000 different devices within their customer base worldwide. And they had built the back end for this thing in 3 geographically dispersed data centers. So they built the buildings, they bought the servers, they hired the people, they were running these things themselves. And there was a set of challenges associated with this. Some of them we've already talked about, the fact that you have to over-provision to meet demand, the whole server utilization economics issue, because you did have a lot of peaks and valleys associated with demand on the system. The fact that there were new data types being used, new document types, streaming media, larger software packages, things that were just putting stress on the system. The fact that this was implemented over a VPN, so there are issues associated with that, including the fact that the customer's firewall had to be configured for VPN access. So you've actually taken a cost and foisted it onto your customer. The fact that the VPN servers themselves had to be able to scale to meet this demand. And so along comes the cloud. This particular division of Siemens was part of our technology adopter program, I think, before Windows Azure was even named. I don't think we'd even announced the brand, and they were already in the TAP program. So they were hot on the trail of doing something about this, probably 2 years before we announced commercial availability of the platform. And essentially what they did is they built an Azure-based software distribution system, and it's actually quite elegant the way that they've done it. What SAP does is gathers up all the orders from customers, and they had an existing SQL Server application that gathered up all those orders, applied the management data to it, the scheduling data, and married it to the software packages that are sitting off in a repository somewhere. And what this new application does is uses that SQL Server application, continues to use that SQL Server application, uploads the whole thing to the cloud. The software packages goes up into blob storage in Windows Azure. The management data goes up into a table in SQL Azure. And the customers, rather than having updates pushed to these devices, basically get a notification that say, hey, the package is up in the cloud. Go get it whenever it makes sense for you. And the customer goes and gets it, pulls it down. The app fires off a notice to SAP. SAP spits out the billing, and off you go. And one of the interesting things about this, and of course the cost, I mean, you can read the quote. We have an order of magnitude cost improvement here. But one of the other important things here is that knowledge, familiarity with things like how to write queries in SQL Server apply to SQL Azure. Right? If you know how to write an app for Windows Server, you know how to write an app for Windows Azure. So the idea that a lot of these skills were able to move forward and take advantage of some of these new scale-out cloud next-gen technologies was a very important lever for them. Here's another one. This is a company you may not have heard of called RiskMetrics. This used to be part of J.P. Morgan. RiskMetrics, this was the part of J.P. Morgan that did high-end supercompute number crunching Monte Carlo sim for market simulations. They were spun out of J.P. Morgan or Morgan Stanley rather. I'm sorry. They were spun out of Morgan Stanley in 1998, and now they provide these same set of services for a number of different companies on Wall Street. They're a Windows Server high-performance compute customer. They built their own data center. They have a server farm that they keep very, very busy, so they actually do a great job of getting efficiency, keeping the machines running, keeping the business coming through the door, but they're gated at the upper limit by how much business they could take on because of the upper limit on this capacity. And what they did is they took this application, there was a .NET application running on Windows Server, and they used Windows Azure to burst that app into our cloud, giving them the ability to take on more customers, take on more revenue, take on more profits without having to spend a dime on a new server. So this is another great example of a quasi-hybrid type scenario where the customer didn't have to throw out the baby with the bathwater, so to speak, didn't have to learn new programming languages, new skills, a lot of new things to take advantage of what we're offering in the platform today. So independent of the technology or the fact that they happen to use our products versus a competitor, the takeaway here is this is fairly representative of how a lot of companies are using the cloud today. So I want to wrap up here and just talk about a couple of takeaways here. I think it's fair to say that whether or not the end state for cloud computing is public cloud in these shared environments, but if it is, economic forces will drive that shift. But in the interim, we are going to see these hybrid scenarios. And by interim, I want to be clear by what I mean by near term. This could be potentially 5, 10, 15 years. think about the automobile and microwave examples, and I know the world moves much faster now than it did back then, but a lot of the innovation that was happening, a lot of the engineering that was happening predated mass adoption by a long, long time. It may not be decades, but it will certainly be years. So what can you do? Get started now. I'm a big believer in first mover advantages. So to the people who move first and identify what the possibilities are, there's a fairly limitless amount of possibilities that you can apply using some of these new capabilities, new technologies, new services. A lot of what's being talked about at the conference this week. So there's just a couple things that I would ask you to do. Come to the keynote tomorrow morning and listen to Aaron Kelly talk about the future of productivity in the cloud. I think you'll find that talk very, very interesting. And of course, if you want more information, we have a booth in the expo hall. We have quite a presence here at the event. And after the event, you can also visit Microsoft.com/cloud and get more information. Thank you very much.
Thank you very much. Tim O'Brien, Microsoft, finishing